But at number 1, write down all those definitions. Molality was.
And then molarity is over liters.
Liters of solution. Liters of solution. So you got them all? Did you forget any of them? Which one did you not get, Daisy?
Yeah, I got them all.
Woohoo! So if you got, everyone done with number 1? Anyone not get finished number 1? Kevin, you got number 1 all done? Alrighty. So write down the number of sig figs in all those. And number 2 then. Matt, did you get all the number 1s? Okay. And remember, when we're working those questions that involve number 1, we don't write the word solute and solvent. We actually put in the chemical formula of that solute or solvent. Yeah, I don't have any list of pick from here. Okay, Jose, how many sig figs in this one? What'd you put for A? How many sig figs? 5? Yeah, good. Oh, thanks, Ashley. Thank you. 5. In B, everybody says 3. C? Yeah, write in scientific notation if you're not sure. So try number 3. Anybody get an answer for 3? Did you get an answer for 3? No? I hear 6.2 for number 3. Anybody else get 6.2? Ah, okay, 6.2. 6.2, 6.18. We probably should say 2.18 because that would match the 2.00 liter sig fig. No. No. I think the only time I'm going to count off for sig figs are in those questions that specifically say, give your answer to the right number of sig figs. Or if it doesn't say sig figs, but it's messing with uncertainties or, well, any plus minus, put it that way. Plus minus of any type, then they have to match, right?
So, what was the kind of flask? A volumetric flask, or?
Yeah.
Yeah.
It has to be a volumetric flask. Anybody not get number 3? Naya, did you get number 3? Yeah. Okay. You know what? Before I solve it, we should do our little trick there, right? Or we start typing stuff out. Like 0.05. Yeah, 12 to 1 moles. All right, that's what this thing means. I think that's how we started writing out a lot of these, didn't we? Did we kind of list stuff out? Okay, there's not much else to write, but you'd start with the 2 liters. All right. And one of those I've got. Someone found the molar mass.
Eric, what's the molar mass from the 3?
461.009.
461.
Grams of PBI2.
Really? That much?
Mole of PBI2.
461? What the heck? That doesn't sound right. What? What's the molar mass for 3? I could. What is it? 61 point something.
Okay.
Okay.
I give you the. I'm doing the 4th one.
Just disregard that guy.
6183. 61.83.
Okay, that's a good warmer-upper one there.
Moles. Do a mole bridge.
Okay. Number of places to start on number 4. Starting points, after you get a starting point, the rest is just kind of canceling units. So Andrew, where did you start? Or where could you start? Okay, we could start here, but just do what to it? Flip it, because then our liters is the same as mils. We can convert. We would have our answer. So that's a healthy place to start. Or you could also start with 100 grams of lead iodide and just convert all the way to mils. But I think this is how we attack these problems, as we looked for our units, looked for our answer. So I like that way. A liter of solution. Let me get rid of that liters right away. All right. So Christina, what would you have to do next? All right. The liters are gone. Did it make sense where Andrew said to start? You can start with 100. That's fine. I like how Andrew started, because that's how we started a lot of those questions. If you remember way back when, here's what we're after: milliliters of Ki solution. So we wrote all this stuff out, and then looked for our answer, and there it is in liters of solution. So he just flipped it. It started with there's our answer. We just have to get rid of everything then. But you could too. You could also start with 100 grams of PBI2. It works that way too. It will. It's the same thing. A times B is B times A. We got to keep going though. What would be the next step? The mole bridge. Because we got to go from Ki, and the only way to get rid of this moles of Ki is using that 100 grams of lead iodide. You don't have any choice. Well, that's a whole different compound. To go from one compound to the other, that's the mole bridge. So moles Ki has to be on top, so it'll cancel. Now we're interested in this. We're interested in this stuff. You have to use it somehow, so let's get it in the lead iodide. And it's what, 2 to 1? Right? Okay. Well, now if you can see, heck, we can get rid of it by. We can't cancel it out yet. Got to get into moles first, right? Have these units keep canceling on you. And it tells you where to go next. We want to leave the milliliters alone, so let's get rid of that moles of PBI2. That's what we have to get rid of. And remember, we have this 100 grams of lead iodide to work with. So let's just get it into grams, so then we get the grams to cancel. We're not there yet, but just find the molar mass of this stuff. Yeah, find the molar mass of that PBI2. Is it 461? Now we can get rid of that grams. So everything cancels but the mils. And you could have started with 100 grams of lead iodide, but the way we started, I think, really prepares us better for more complicated problems that are coming up.
I got like 1730.
1735 milliliters?
Yeah.
That's a lot. No. The only time we're going to worry about sig figs is if the question states it, or it involves anything with plus minus. Okay. Oh, Daisy. There's a hint in there. What's the hint in there on how to handle that question? Do you remember this? This is weeks ago. If you have two big M's, you know it's going to be what type of question? MI/VI equals MF/VF. It's a dilution problem. Especially two big M's, I guess we should say, of the same compound, right? That's kind of, we should probably notice that. Two big M's of the same compound.
This is just an idea. Can you figure that out through like conversions?
I think I tried once, and then it just got so dang ugly. I don't think it
'Cause
works.
you have to like, I was trying to get it like the grams of solute in each solution, and then trying to figure out like how many grams I would need for the next one.
Well, it's going to be the same grams of solute in both of them, and that's the
yeah.
trick. If you realize that, you'll get it to work.
So you just set up.
And this is the how would you prepare, so you need to make a statement at the end.
We need 250, which is 0.25
Will you leave it in mLs, right, because it doesn't specify?
It doesn't care. But you need to make a statement at the end.
Oh yeah, we do leave it in. I guess it's better. Equals
All right, remember this kind of thing? Get it, Jenny? Did you get 17 mils? Okay, then how do you make the sentence then? Remember, it was take VI of MI and dilute to VF to get MF. That's how I remember it. One student got 17 mils for their VI. Okay.
250 mils.
Did we take it 18?
Hmm?
I got 17.9.
I don't know. Jenny, what'd you get? 17.85?
17.8.
Oh, it is 17.9. Nope. Right. Take VI of MI and dilute to VF to get MF. Yep. Yeah, that's how we memorize weight percent.
The decimal point over to
Okay. Okay with 5?
So I need to know the quantity is. So I'm gonna start with is.
I just made up a lot of this stuff. So that's why we're kind of doing it together. Oh, yeah. Sorry. It's also online. Right? Well, it will be online.
Are you using the new or the old online?
We don't. I make online?
I mean, Blackboard, sorry.
Mateo. This is YouTube. And what's our channel? Why am I going through all this?
Tried for like 2.5 years.
Chemistry with D.R. Smith.
Check that out.
Jeez. So I take it you're not part of one of my 21,708 views as of today. I know. It's gotten up there. Over 100 subscribers.
Wait, once you get like 10,000 views, don't you start getting paid?
Oh, that's for one video, and you have to have advertisers on there and stuff.
I was gonna say you're gonna get paid.
We'll keep visiting it. And then
We will.
Yeah, it isn't worth it. It's too distracting, I think.
All of us will just get on all at one time. One day.
So I think this is a good one to start out with how Andrew started the last one, even though it looked a little more complicated. Write out everything how we want it written out, at least how I want it written out for number one. That's your starting point. Like, or no, we did it this way. I guess you could do it this way. So I strongly suggest knowing that number one, because where to start's just staring at you if you do it this way. It really is. Sochi, where do you start? The first one, and what do you got to do? Flip it. Exactly. There's your answer. Right here. There's your answer. Well, the units of your answer anyway, right? So start by flipping it. So the next step would probably be what, Jesus? What would you do next? Find a way to get rid of those grams. Yeah, find a way to get rid of this one. Find molar mass. Good, because when you look at this other stuff, it's all in terms of magnesium hydroxide, different compound. So if you use molar mass, you get it into moles. Then you use mole bridge, and just keep going from there. Right. See if you can knock it out. What'd you get? Did you get final answer?
Yeah, I got 75.75.
75, was it grams?
Yeah.
One person got 75 grams as the final answer for this.
For the entire problem?
For the entire problem, 75 grams. This is grams of solution. Grams of solution. So weight percent is grams of solute over grams of solution. And that's what they want. They want to know how many grams of this solution. So that's why we started by... Oh, okay. Because according to our... When you read the question, you write down everything like we did. Like 24.8 grams of calcium sulfate per 100 grams of solution, all that kind of. Write them all out. And then you look at the then you go back and read the question, right? So how many grams of this, who cares, solution? So you need to find grams of solution. So you go back and you look at everything you wrote and find grams of solution. And there it is. It's in the very first term on the bottom. But to have an answer, it has to be on top. So we flip it. And that's where you start. In a mole of calcium sulfate. Right? Now you're ready for the mole bridge. Yeah. Yep. See where to start?
No, I'm actually still trying to. I did something wrong before that I cannot figure out. I keep coming up with 20 over this answer. I do not see what I'm missing because I've got the 100 grams is what I want. So I knew that, and I went.
You sure 360 is right?
Double check.
All right, that should be fine then. One of those. 2 KIs. 0.25 moles. I don't see what you did. It looks perfectly fine to me. It looks right. All right, let's finish this guy up. What's the molar mass of calcium sulfate? 130. Thank you, Kevin.
Oh, it's the error. You just got the error, you just got the case. Oh, sorry, you like it?
You just bought the case.
My stepmom has
Like that? Okay, and then...
Well, I bought, like, when I bought my laptop, I had to buy all the Microsoft Office, so my friend bought it for me at CSA at $30. Oh, yeah, but here's expensive. How much is it?
What's that?
What's the formula mass of NGOH2? What is the formula mass of NGOH2?
You don't need the formula mass.
Oh, you don't?
Yeah, you're going too far then.
You probably put one
Right here, after you do your mole-to-mole ratio, then you go into one.
What'd you get as the final answer?
I got 75.8.
75.8.
Oh.
Okay.
Yeah. That's what I wait. Okay, yeah. So then at this step, I tried to do another formula mass.
Okay.
Yeah. Okay.
But the real trick to this is knowing number one. Know the first question, so then you can write out all these terms like this. It's key. It's just key. Okay? It's good? A lot. It's a good question. How many problems will be on the test? There's a lot. The reason why there's a lot is because you are really adept at working these questions if you know exactly how to start each one. If you know exactly how to start each one, you're going to have plenty of time. If you do not know how to start each one, you're going to be in trouble. That's why the exams are written the way they are. And the reason why they're written that way is because it's identical to the homework, identical to what's done in class. It's not an application of that. Therefore, since it's the same material, it's going to be a lot of it. And that's how we assess your ability. So when you see a question like this, you want to have a mode on how to attack it. And here's my mode that I've been trying to get you to do. Right? And you spit it all out and do the game plan, look for your answer, like Sochi said, right here, flipped it. So there's no hesitation. You know exactly what to do. And then you'll be fine. You'll be fine. The exact number of problems, I'm not so sure. Okay. Okay with this one? Good question. Okay, here's another one. Okay. Does anybody have a game plan for number 7? Yeah, I'll write out everything again, except just we'll do that. We'll start out the question just like we did here, but I just want you to realize something. 50% excess.
1.5 times the voltage.
1.5 times whatever your final answer is. You don't care about this excess stuff. You handle that at the end. Exactly what Eric said, just multiply it by 1.5, right? Whatever you get as your final answer, multiply it by 1.5 and you're done. It's kind of like the last one. If we wanted a 50% excess, just multiply this answer, 75.8, by 1.5, and we'd be done. So this whole excess thing, just block it out and pretend it's not there. Just don't forget to handle it at the end. Well, yeah, you could just multiply it by 0.5, see what it is, then add it to your answer. That's the same as multiplying it by 1.5.
We need to figure out grounds about this. So I'm going to start with grounds of solution.
Oh, how many grams in that solution?
The molar mass, do you add the hydrogen? That's not in the equation.
What's that?
Do you add the weight of the hydrogen? The molar mass is also in the equation.
I think you do.
Where are you at?
Because like it says of aqueous HF, and we need to get the formula mass to get it into moles. But in
I would have to start
equation,
solving it to see.
Well, in the equation it's just 4F, so she's asking, do we include the H?
Yeah, let's get there, then we'll see.
I think you do.
So we can answer. Well, let's get to that question on here, then we'll answer it. So where would you start? This guy flipped. Everybody agree? Start with that guy flipped, because there's your answer. Right? So I can't stress enough to write the question like this. Right? And then your answer is staring at you. So flip it. Okay. So we got to get rid of grams of HF. Oh, so this is what you guys are asking about from the very beginning, the very first step. Yeah, grams of HF has to cancel. So what this first step is going to be the molar mass of what? HF. You have to, because that has to be the molar mass of HF. Well, the more digits you carry, the better you match with the back of the book and everything else. So I don't think you need to write 12.0107 for carbon, but 12.01 would be good. Okay. So what would you write for molar mass? 20? Okay, now what? Well, yeah, we could do mole bridge, but technically HF isn't in the mole bridge. So let's just, I like this step. I mean, you could, but it looks cleaner if you have mole HF here. And what is in the mole bridge? F is. Ah. So just looking at the chemical formula of HF, what's your mole ratio here of HF to F? 1 to 1. It's just cleaner this way.
So you don't have to keep skipping.
Yeah, you can skip it, but to me it's cleaner. Why go through all this work of units if you skip stuff like that?
What was it that you were talking about skipping?
Oh, ask Daisy. I'm not going to talk about that. All right, now you're ready for mole bridge, right? Oh, mole HF. I didn't cancel my mole HF. Now you're ready for mole bridge. It's cleaner. Now you're ready for mole bridge. Yeah. Mole F minus has to cancel. And you have 4 moles of F minus for every one mole of, what is that, thorium or something? 4? Val? Yeah.
Can you explain why it's 1 mole of, so you're doing the hydrogen 4?
You talk about this?
Yeah.
Okay, you can play that. You can play this game with any chemical formula. Like if I had 1 mole of calcium carbonate, how many moles of how many moles of oxygen would I have? Looking at the chemical formula. If I have 1 mole of calcium carbonate, how many moles of O would I have? 3. Just put a 3 there.
Okay, so you're just using the backwards.
You're just using the chemical, because these are mole ratios. Chemical formulas are mole ratios. And I like to have it in there because and Daisy's right. You could skip it because it's 1 to 1, but I don't like to skip it because what if it's not 1 to 1? Look at the oxygen step. That's not 1 to 1.
Yeah, Daisy.
All right, we should probably finish this, then we'll hand out the quiz.
Dr. Smith, could you say that again? What if it's like not 1 to 1 on the HF and F?
Well, yeah, let's say HF was actually HF2, right? Then you'd have to have a 2 down here, right? But it's not, so.
Do you just have to remember the Q table? Oh no, they tell us all that.
Okay. So yeah, put everything away. Anybody get a final answer, by the way?
14.4.
14 point something?
14.4?
Well, 14. I hear a bunch of 14.4s. You're the skipper. I won't go by you.